All right, so I think this is is this recording? Yeah. All right, I think I'm recording. So we have this application problem that Jill stands 300 feet from the base of a skyscraper as she looks toward the top of the tower. Uh, the angle of elevation is 64 degrees. What's the height of the skyscraper? So let's make a sketch real quick. We have some skyscraper, maybe maybe it's Trump Towers in New York. I don't know. We're ignoring the Jill's height, so I'm just going to draw it from the ground, but from where Jill is standing. Uh, she's standing 300 feet from the base and we're assuming that it's not the Leaning Tower of Pisa, that it's square with the ground. If this is our ground, and she looks towards the top of the tower, so she's looking up. The angle of elevation. So when if she's looking just horizontally, she's got to tilt her head back to look up. So that's the angle of elevation. Her horizontal line of sight is parallel with the ground. When you tilt your head back, when she tilts her head back to look up, she's got to tilt her head back 64 degrees to look up and see the top of the tower. So it wants the height of the tower. So if we, there's the sun. Which trig ratios would we use if we're interested in a leg and given the other leg from our SOHCAHTOA? Well, it would be tangent. So the tangent of 64 degrees is equal to the opposite leg, which is the height of the skyscraper, divided by 300. So to find the height of the skyscraper, and we can uh, we can round it like to the nearest tenth or something like that if you want. So let's check the mode. We are in degrees, and if we just round it to the nearest tenth, let's take the 300 times the tangent of 64, 615.1. So 615.1, and the 300 was in feet, so the height of the tower is in feet. So there's our answer for this one. Let's do the next one. Batman. All right. Batman stands on the top. I didn't expect that. Batman stands on the top of a 250 foot tall building in Gotham. As he looks over the edge, he observes criminal activity at an angle of 82 degrees depression. What's the horizontal distance from the bottom of the building to the criminal activity? All right. So again, we've got Batman. And there's his hood and his cape. So yeah, that's a bad looking Batman. So we've got Batman on the top of a 250 foot building. Um, we have criminal activity down here. So we've got a mugging or something going on. All right. Uh, the building is square with the ground, and what's the horizontal distance? Well, horizontal left and right from the bottom of the building, to the criminal activity, we just call that X. Now, the angle of depression, if Batman is just looking out horizontally, when he tilts his head down to see the criminal activity, that's the angle depression. So it's this angle right here is 82 degrees. And that two parallel lines cut by a transversal, alternate interior angles are congruent. So if he has to tilt his head 82 degrees down to see them, they would have to tilt their head 82 degrees up to look at him eye to eye. All right, so let's come over here and do our work. Now that we have our criminal activity and Batman, who apparently is going to hopefully stop it. So we've got information about the legs, and it's not saying how far does he have to glide or travel to jump off the building to get down there. So the tangent of 82 degrees is the opposite leg over the adjacent leg, 250 degrees to 250 feet divided by X. If you cross multiply, if you just exchange the X and the tangent of 252, or tangent of 82, and now we can jump to the calculator. Gosh, I almost read that as 280. 250 divided by the tangent of 82. 35.1 feet. So they're relatively close to the building and stuff. All right. Let's take a look here. Oh, we don't have any Batman or Superman. A loading ramp is attached to the back of a semi-trailer. If the height of the back of the truck is 4 feet and the length of the ramp is 10 feet, determine the angle the ramp makes with the ground. Alright, so we have the ground, we've got some semi-truck, or at least the trailer of the truck. And we have a ramp on the back of the truck like this, so that we can load up the truck. All right, now the height, if the height of the back of the truck is 4 feet, the length of the ramp. So when it's referring to height of the back of the truck, 4 feet, that, I believe that's just the 4 feet off the ground, and the length of the ramp is 10 feet. So I would assume here's the ramp. It's not the ground. It's not the base like it was before. So this is the right triangle that I'm going to use. The hypotenuse here is 10 feet. The height to the back of the semi truck, and it wants this angle that it makes with the ground, that the ramp makes with the ground. So with respect to this angle, the opposite leg over the hypotenuse is the sine. So since I want the angle, we'll take the inverse sine. Alright, now we're in degrees, so our angle measure that it's going to give us is going to be in degrees, and it's going to be rounded to 1 decimal. And that seems reasonable. That's fine. If the directions told us something different, we would just key it in different. So we hit the inverse sign, 4 divided by 10. We don't even need to reduce it or put it as a decimal. We'll just let the calculator, 23.6 degrees. So there's our answer. Not as fun as the Batman problem, but alright, so let's take a look at this. A fire department's longest ladder is 110 feet. According to regulations, it can be used for rescues of up to 100 feet. What angle does the ladder make with the ground in this situation? Alright, so we've got the ground. Let's say that we've got some building, and the building is on fire. So the fire department has been called to put out this fire. So they have this ladder, and the ladder is a 110-foot ladder. So we're assuming that the building is square with the ground, that we don't have the Leaning Tower of Pisa, and they're saying that you see, you don't want this ladder up flat against the, just flat up against there, because that would just be too rigorous for the firemen to climb, a vertical ladder. So they do expect them to be in shape enough to climb a ladder that is pretty steep. They want to be able to reach up to a height of 100 feet. We need to know what angle they are allowed to. They don't want to exceed. They don't want that angle to be greater than this. So if we look at that right triangle, and that's going to be the difficulty in these problems, is finding the right triangle within your picture. You can have fun with it, with drawing the fire or firemen going up the ladder, or whatever. But the sine is the opposite leg over the hypotenuse. So the sine of angle theta is 100 divided by 110. This angle theta is the inverse. We'll have the calculator give us this angle. So if we jump to that, we've got 100 divided by 110, 65.4 degrees. So that's pretty steep. This, you don't want this angle to be greater than that. If it's greater than that, then you could reach up more than 100 feet, but it could put people in jeopardy, getting them down the ladder or getting the firemen up the ladder. I'm assuming that's why the regulation exists. All right, let's see. Oh, hey, that was it. So talk to you later. Bye.